Hey, welcome back to Well, That's Interesting, the holy shit edition. Today is episode 261, Rogue Planet growing at a rate of 6 billion tons per second, and how reindeer help in the fight against climate change. My friends, we are dead smack in the middle of the holiday goddamn season, which means two things. One, you're trying to find brand new ways to politely decline invites to certain social situations because you've already used all the excuses from last year. And two, you're delightfully, unapologetically, unashamedly eating more than is reasonable at the social situations you actually want to be a part of. Today, we are going to celebrate numero 2 with topics that are equally as filling and flavored with so many delicious facts, you'll have to unbutton your pants right in front of me. In the first half of the show, a planet that defies convention. According to the still-functioning website science.nasa.gov, in 2006, the International Astronomical Union, or the IAU, a group of astronomers that names objects in our solar system, agreed on their own definition of the word planet. With a finger pointed into the air, they declared to qualify as one, it must do 3 things. 1, it must orbit a star. 2, it must be big enough to have enough gravity to force it into a spherical shape. 3, it must be big enough that its gravity has cleared away other objects of a similar size near its orbit around the sun. Done and done. Am I right? Of course not. NASA goes on to say astronomers and planetary scientists did not unanimously agree with the IAU's definition. They pointed their own fingers into the air, expressing nerdy questions and concerns like, "Dear sir, I have reservations about point number 2. Such a simple definition does not take into account what degree of measurable roundness is needed for an object to be considered round." For real. That was an argument. How round are we talking here? So what I mean to say is that the definition of a planet is still evolving, especially when something like CHA 1107-7626 is found. Now, what the hell is that? Great question. Discovered a mere 2 years after the IAU's definition in 2008, it immediately threw a galactic monkey wrench into the terms and conditions of what makes up a, quote, planet. It's 5 to 10 times the mass of Jupiter, which is, well, massive, but not large enough to condense into a star, with a thick with a Q core stable enough for long-term nuclear energy production. It's well below the 80 Jupiter mass limit for that to happen. So, it's not a star. So is it a planet? Well, let's take a look at its environment. Surrounding Cha is Chameleon, a star-forming complex that's actually one of the closest stellar nurseries at 700 light-years away. But no stars are in Cha's vicinity, so it's not orbiting anything. It's actually out there alone, hurling through our galaxy, having the time of its life with all that star-making material, not becoming a star, and not becoming a planet as we know it. We will get into Cha's official title, that of a free-floating planetary mass object, or rogue planet. We will be amazed by just how fucking many there are. We will meet the team that's keeping an eye on Cha to see what becomes of it, and its recent activity that puts all eating competitions to shame. Then after the break, Santa may not be real. Oh shit, sorry kids, but reindeer are still delivering a very special gift, a habitable planet. Now, if you're a long time listener of this show, then you know it's only a matter of time before researchers confirm what indigenous populations already knew. Have a listen to episode 205. This desert beetle may save humanity when water runs out, and this 7,000-year-old indigenous myth may be a true account if you haven't. That's just one example. In a recent interview with Erica Benke of the BBC, Tia Jeremy Jeff, a reindeer herder in northern Finland and a person of Sami descent, plainly but profoundly stated, quote, "Reindeer eat lichen and other plants. They also trample on them, so they make sure the vegetation is not too thick, and that keeps the ground colder. Thick vegetation on the ground would trap a lot of heat. If there are no leaves and grasses, the ground gets more frozen, and it freezes earlier in the winter." End quote. my friends. As also reported by the BBC, research shows that global warming is in fact accelerating the shrubification of the Arctic, which is just a bushy way of saying warmer, longer summer seasons speed up plant growth, which traps heat, causing even more plants to grow in a place that should be a winter wonderland. It's quite possible, however, reindeer can help put a stop to that thanks to their appetite. We will take a look at the team that took Tia's observation and turned it into a study with hard numbers. We will look at those numbers and say, well, god damn, this may just work out after all. In the meantime, hi, I'm Jill Chacha, and I'm not a free-floating planetary mass object, not yet anyway, but if this is your first time listening, welcome to the flock, my celestial business goose. To begin, I have great news. I'm about to take all of us to the middle of nowhere in the dead of night. Oh yes, indeed, the plan is to stand with our necks strained to the sky under the Greater Big Bend International Dark Sky Reserve, which is one of the world's largest international Dark Sky Association certified sanctuaries covering over 15,000 square miles across Texas and Mexico. This is a fancy way of saying, yeah, there's a global non-profit organization solely dedicated to protecting the night sky and combating light pollution. And their crown jewel is an enormous stretch of land located in southwest Texas, spilling into northern Mexico. The remoteness and the dry air make it one of the best places on Earth to see stars. The total number is overwhelming, inspirational, and may even bring some of us to tears. But you know what? Whatever that number is, it's dog shit compared to the number of rogue planets in our Milky Way. Yeah, you heard me. In an interview with Ashley Balzer of NASA.gov, David Bennett, a senior research scientist at NASA's Goddard Space Flight Center, said in a statement, quote, "We estimate that our galaxy is home to 20 times more rogue planets than stars. Trillions of worlds wandering alone." End quote. Yeah. So the next time you're sharing a profound, indescribable emotion under a starry night with someone, lean over and whisper into their ear that for every star you see, there could be up to 20 rogue planets zipping around like Hell's Angels out there bound to no one, worshiping no god. And by now, you may be thinking, damn, I really wasn't expecting that. What are rogue planets exactly? How could there be so many? Where did they come from? Great questions. Officially called free-floating planetary mass objects, these babies were first spotted only 25 years ago. And as such, we are just scratching the surface with what little we know. So let's start with that. As the name suggests, these objects aren't tethered to any star. So to find them, the option to use the transit method is completely thrown out the window. That's when researchers, hoping to discover an exoplanet, aim their sights at said stars for days and weeks on end, hoping to catch a dip in their brightness. If that dip occurs in a repeated, predictable amount of time, then you might have yourself a planet orbiting it. But here, no such luck. And to be honest, at the moment, luck needs to be on the researchers' side when looking for these things. As of the release date of this episode, there are 2 ways you can find them, and I envy no one who has to use them. As Dr. Alfredo Carpenetti of IFL Science explains, when it comes to the first method, quote, astronomers have to wait for a fortuitous alignment. If a rogue planet moving through the galaxy passes in front of any star from our line of sight, it will slightly boost the star's brightness. This is known as microlensing, a type of subtle gravitational lens effect. End quote. Now, although microlensing feels like leaving a lot to chance, on the upside, a transit can take a few hours to a day, and the amount of information collected in that mere time frame can be revealing, like the rogue planet's mass and chemical makeup. Thanks to the literal handful of rogues found with microlensing, we've discovered some common characteristics. Generally, they're below the 80 Jupiter lower mass limit needed for star formation, meaning to transform into something like our sun, they'd have to be minimum the mass of 80 Jupiters. And they also fall well below the brown dwarf limit as well. Now, what the fuck is that? Don't worry, I've got you. When a celestial mass falls between 13 and 80 Jupiters, they are what I would rudely consider a failed star, or a brown dwarf, because they don't have enough mass to ignite and sustain nuclear fusion of hydrogen in their cores. Instead of hydrogen fusion, some brown dwarfs fuse deuterium, a heavier form of hydrogen. And if they're at the larger end of that scale, it's lithium. So, rogue planets are generally low-mass objects, and thanks to the painstaking work of David Bennett, who I quoted before, and colleague Takahiro Sumi, a professor at Osaka University, it's believed most rogue planets are on the rocky side. Now, if microlensing leaves nearly everything to chance, the second method leaves absolutely nothing to it. This involves so much attention to detail and obsession, it makes me want to weep. Here's what I mean. The Canada-France-Hawaii telescope, located near the summit of Mauna Kea on Hawaii's Big Island, is a favorite on this show, and it just made fucking history. From cfht.hawaii.edu's article, Largest Collection of Rogue Planets Discovered in Our Milky Way, quote, a team of astronomers led by Dr. Nuria Miret-Roig from the Laboratoire Astrophysique de Bordeaux, nailed it, and the University of Vienna, announced today in the journal Nature the discovery of at least 70 new rogue planets in our galaxy using data from telescopes around the world, including CFHT's suite of wide-fielding imaging cameras. The team utilized the fact that in a few million years after their formation, these planets are still hot enough to glow, making them directly detectable by sensitive cameras on large telescopes. To find these planets, Dr. Nuria used observations and archaeological data from a number of large observatories, including CFHT, facilities from Noir Lab, telescopes of the European Southern Observatory, and the Subaru telescope, amounting to 80,000 wide-field images over 20 years of observations. These 80,000 observations measured light across a wide range of optical and near-infrared wavelengths, and combined them with measurements of how they appear to move across the sky. They found at least 70, and possibly as many as 170, new rogue planets with masses comparable to Jupiter's in a star-forming region in the expansive Upper Scorpius and Ophiuchus constellations, just a few hundred light-years away. We measured the tiny motions, the colors, and luminosities of tens of millions of sources in a large area of the sky. These measurements allowed us to securely identify the faintest objects in this region, the rogue planets, explained Dr. Nuria. End quote. Woo, my friends. That was exhausting. It is exhausting. But it leads us to a rogue planet living up to its name. Speaking of being hot enough to glow and being found in star-making pockets in our galaxy, we need to talk about CHA 1107-7626, who I'm just going to call Cha from here on out, because who has time for that? Please, join me, will you, with a massive team of 9 research institutions throughout Europe, including the University of St. Andrews, the Astronomical Observatory of Palermo, and the National Institute of Astrophysics in Italy, who just collectively exclaimed, "Mamma mia." For the past year, they've been tasked with babysitting a collection of rogues, specifically keeping a watchful eye on Cha, a low-mass object 5 to 10 times the mass of Jupiter, located a mere 620 light-years away, within the dense star-making clouds of Chameleon. Now, when you have something like the James Webb Telescope and the European Southern Observatory's Very Large Telescope, the VLT, at your fingertips, it makes the job of tracking these rascals a lot easier. In fact, with the JWST and the VLT in place, like any good babysitter, you can walk away and grab something from the fridge and send a few texts. It basically does the work for you. Then you can saunter on back to your overseeing duties like a champion and leave when the day is done. Well, the day was done in late August. And like a lot of babysitting gigs, it didn't go exactly to plan. According to the team's study, revealingly titled Discovery of an Accretion Burst in a Free-Floating Planetary Mass Object, after looking at the incoming data, In April, May, and late June of this year, 3 bursts of light were recorded by VLT's X-shooter spectrograph, which is just a really fancy instrument that separates light into wavelengths or colors to create a spectrum. And baby girl, these bursts were making all sorts of colors. And it didn't end in June. 2 more bursts were picked up by JWST mid-July and as recently as early August. As reported by the tremendously appropriately named Michelle Starr of Science Alert, these sudden bursts of light are typically associated with an episode of accelerated accretion. Now, what the fuck does that mean? First, it means to sit the fuck down and to hold on because, 2, we're about to enter into the realm of unfathomably large numbers. My friends, you and I have covered many a black hole on this show, so accretion should sound a bit familiar. The sheer gravitational pull of black holes spaghettifies, yes, that's the official term, spaghettifies every atom that finds itself too close. They're ripped apart, with all the bits slamming against each other as they swirl the drain that is the black hole. This swirl is the accretion disk. This process is so violent and intense, energy is released in a number of forms, including light. The only reason we can physically see black holes is because of this energy being released, from this material being pulled to shreds and that debris slamming into each other. Well, I have great news. Something similar is happening here. By comparing the light emitted before and during these new bursts, the team was able to do some clickety-clack calculations, and they came to the jaw-dropping realization that the amount of material being chewed up and swallowed by Cha is approximately 6 billion tons a second. Yeah, let's lean into this. To really feel the heft, let's take a moment of silence for 3 seconds. Okay, in that time, Cha inhaled 18 billion tons. If that seems utterly insane to you, it is, and you're not alone. Quote, people may think of planets as quiet, stable worlds, but with this discovery, we see that planetary mass objects freely floating in space can be exciting places, said Victor Almendros Abad, an astronomer at the astronomical... I'm sure I did not say that correctly. I'm going to say it slower. Victor Almendros Abad, an astronomer at the astrological... the Astronomical Observatory of Palermo and co-author of the study we're chomping into right now. I am so sorry, Victor. Now, continuing his quote, this is the strongest growth rate ever recorded for a rogue planet, or a planet of any kind, end quote, from the team's October 2nd press release. Victor, this is exciting, to say the least. We are now witnessing, in real time, a rogue planet that is still growing, still using the star-making goop of chameleon as its charcuterie board. And guess what? It's not solely using gravity and its low mass to do it. Not only is this binge breaking records, but how it's happening is a first as well. More from that press release, quote, magnetic activity appears to have played a role in driving the dramatic infall of mass, something that has only been observed in stars before. This suggests that even low-mass objects can possess strong magnetic fields capable of powering such accretion events. The team also found that the chemistry of the disk around the planet changed during the accretion episode, with water vapor being detected during it, but not before. This phenomenon has been spotted in stars, but never in a planet of any kind. End quote. Okay, huge side note. If you want to hear more about the relationship between water and stars, I've got you. Listen to episode 259 if you haven't. Anyway, today we've got low-mass objects, but also magnetic activity, water vapor, apocalyptic accretion episodes. Y'all, Cha is a rogue planet, totally blurring the line between star and, well, planet. That is super cool. But it's also showing us one way these objects are formed. Prior to Cha, there were two theories. Found nestled within dense clouds, it's possible they form like stars do, inhaling stuff, or two, they develop around a star and get the old slingshot into space thanks to impacts and gravitational interactions as solar systems settle down. Today, we can confirm that at least one of these is true, what I'm dubbing the charcuterie board method. And to be honest, I think it sounds a lot sexier than accelerated accretion. But that's just my opinion. After the break, we are leaving ravenous planets of the Great Yonder and coming back to Earth, where we're going to meet some ravenous reindeer who are saving the Arctic. Some good news is next. Stay tuned.
When the holidays start to feel a bit repetitive, reach for a Sprite Winter Spiced Cranberry and put your twist on tradition. A bold cranberry and winter spice flavor fusion, Sprite Winter Spiced Cranberry is a refreshing way to shake things up this sipping season. And only for a limited time. Sprite. Obey your thirst.
Oh, Hilton stay, your beds are soft and cozy. No lumpy couch, no stiff futon, no shower line at crack of dawn. Oh, Hilton stay, our holiday you're saving.
When you want holiday comfort you can count on, it matters where you stay. This season, enjoy spacious, comfortable rooms and friendly service when you book with Hilton instead. Hilton for the stay.
And we're back. We are so back. And my friends, I'm going to need you to slap on not one, but maybe two of the heaviest winter coats you own, because we're about to eavesdrop on an interview Erika Benke of the BBC is conducting in the remote village of Kirrinki, Finland. And for my fellow geographically challenged Americans who may be wondering why in the holy hell we're heading to somewhere so cold in December and where this is exactly, don't worry, it's totally worth it, and I've got you. Please imagine Germany. Danke. Point to the northern coast and move your finger up over the Baltic Sea. Here we are in Sweden. Now, one more time, move that pointer to the right over a body of water called the Gulf of Bothnia. And voila, we're in Finland. Kirrinki is nearly as far north as you can go, located 68 miles up from where the line of the Arctic Circle begins. During this interview, it's negative 15 degrees Celsius or a balmy 5 degrees Fahrenheit, and about 8 inches of snow has fallen overnight. But that doesn't stop Tia Jeremy Jeff, a reindeer herder and a woman of Sami descent, from tending to her very own flock while having a good chat. In the 3-minute video I'm about to play for you, we're going to hear about Tia and the Sami people's close connection with reindeer and the observations this population has made generation after generation as the climate becomes more extreme, and thus affecting the environment here. They also talk about how their reindeer may be helping out, mitigating this clusterfuck. So, let's have a listen to a video titled The Unlikely Engineers of Lapland's Ecosystem by Erika Benke of the BBC. Here we go.
The areas where reindeers are grazing, the permafrost is melting slower. We are kind of like engineers of the ecosystem. What a beautiful day it is. It's about minus 15. Tomorrow it will be like minus 30. My partner is full-time reindeer herder, and his family has been their reindeer husbandry business for 3 generations, and now we continue with that. We do have like approximately 1,000 reindeers in our herd. What is amazing, they can actually smell the lichen under 90 centimeters of snow, and then they start to dig. They eat the lichen and the plants on the forest floor. They make sure that it's not too thick.
So they eat the lichen and leaves that would otherwise trap heat and warm up the forest floor.
Yes. People who live in Lapland, they have sustainable way of living. Like us, we produce our own reindeer meat, and then We also have cows that we use for dairy products. We rarely have to buy these two from the store.
You hardly ever need to go to the supermarket, do you?
Yeah, hardly, because it is also a long way to go.
How far away is it?
It is 70 kilometers.
Reindeer is very important for Sami people and Sami culture. So if we don't have reindeer, we don't have Sami people. 1920 winter was a disaster for reindeer herding. Lots of snow, and then we get rain, and then we get again some minus degrees. We had layers with very heavy snow and then icy covers.
The reindeer can't dig through the ice to find lichen, so you have to feed them.
Yep. Because we have had very many loggings in these areas, so we don't have any more this old growth forest here. The reindeer belong to this nature habitat. It's quite open and wide, the forest here. That's because of the reindeer. But if or when it gets warmer, so everything will grow much, much more faster. To keep the forests open, we need reindeer. Nature is everything to Sami people, and we respect it very much. Nature gives us and nature takes from us. But we have to give back also to the nature.
Well, there you have it, my friends. Erica Benke of the BBC interviewing Tia Jeremy Jeff, a reindeer herder, and one of about 100,000 people involved in herding 2.5 million domesticated reindeer in 9 countries. She's also a member of the Sami community, one of more than 20 different indigenous communities in the Arctic. And as you just heard, these reindeer are not only like family, but they're also kind of heroes. Speaking from personal experience, Tia has noticed an increase in plants and moss over the years. And it's the landscaping of her 4-legged crew that's been keeping it all in check. They eat and trample the plants whose rotting matter produces CO2, and whose density seals in heat, warming the tundra, causing snowmelt, which in turn allows more plants to grow. They help stop the cycle. This kind of narrative caught the attention of doctoral researcher Nora Cantola from the University of Oulu, who since 2020 has been gathering evidence to support it empirically, like with numbers and shit. Well, I am thrilled to say she and her very cold colleagues just released a study that measured the impacts of snow cover and reindeer grazing on the carbon cycle in northern Finland's coniferous forests during the growing seasons between 2019 and 2023. And girl, it is awesome. Let's get into it. First, join me, will you, at Oulanka National Park. So far northeast in Finland, it borders Russia. For the past 25 years, reindeer grazing has been forbidden here. So it's one of the perfect places to use as a control and get accurate snowfall measurements. Another picture-perfect place is the Kivo Strict Nature Reserve, which, like its name, is not fucking around. Finland's shape resembles something of a comma, and if you point to the very top of that comma, there's Kivo. Ain't nobody going there, not even reindeer. But still, they've been officially banned from grazing here for the past 55 years. The team also took carbon release samples and snow level readings from 42 other plots in Finland's pine forests, where reindeer were allowed to chow down. So, when comparing the carbon release samples and snow levels of each place with and without reindeer, what did the team find? Drumroll, please. Thank you in the back. From the University of Oulu website, quote, in the area where reindeer grazing had been excluded for 55 years, shallow snow increased carbon release from the understory and soil. In contrast, deeper snow decreased carbon release at the same location. In areas with ongoing grazing and in the 25-year-old exclosure, carbon release remains stable regardless of changes in snow cover. It is notable that snow depth did not affect carbon exchange in areas with ongoing reindeer grazing. End quote. So, my hungry business goose, For the first time, we have evidence that reindeer grazing has an impact on the carbon cycle in the long term, and that the Sami people were totally right. In an interview with good old Erica Benke of the BBC, Nora explained that the data from this study suggests that excluding reindeer for 20 years may not impact CO2 release, but exclusion for 50 years may have an impact. Quote, "It's a preliminary finding, but it appears that carbon release from the undergrowth may interact with snow depth when reindeer have been excluded for several decades in an area in the far north of Finland. So it seems that reindeer grazing down the vegetation on the forest floor could help reduce carbon release to some extent under changing winter climate in the boreal forests as well. There's less biomass to decompose when the reindeers are present, which could further reduce CO2 emissions." End quote. That's right, y'all. Reindeer aren't playing any games. They're a buffer helping to fend off future catastrophe. Thanks to their stomachs and their pointy hooves, they remove insulating shrubs and help slow the melt. And this is super important, as preserving the snow cover reflects sunlight and keeps the tundra chilled. They also eat and shred layers of dead plant biomass that's pumping out CO2. So all of this is great news. So, if you partake in a certain custom where you leave cookies out for an old man using slave labor, may I dare say, leave out some lichen and moss for the reindeer instead. And thank you for listening, rating, subscribing, following, telling your friends about rogue planets. There's more rogue planets than stars because they're not really stars or planets. They're just out there doing their own thing. What a fucking inspiration for next year. That should be you. Just, inhale 6 billion tons per second. It's totally... Reindeer. Also, wow. Heroes. And a chewy thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family. And please, stay interesting.